This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're talking about inverse trig functions, Unit 7. These are the second day of notes. And for these first couple examples that we're going to talk about, I'm going to go into a little bit more detail than we really need to, but that'll just set us up for when we get to a little bit more complicated examples. So remember, anytime you see an inverse trig function, you want to be thinking, okay, this represents some angle. Okay, we don't necessarily know what the angle is, but I know that this whole highlighted thing means, okay, there's an angle where the cosine is 1/7. That's really what we're looking at. So this represents some angle where the cosine is 1/7. Okay, so if I look at this on a unit circle, I know we have to be somewhere in the top half, so I know I'm going to be over here somewhere. So that means I have some triangle where the cosine, which is adjacent over hypotenuse, is 1/7. So I have an x value here of 1. I have a radius here of 7. I could find this y value if I wanted to, and we will once we get to example 9. But for this, we really don't have to. So again, I want to think about this as the cosine of some angle. I'll just call it theta. And I can see, here's my angle theta right in there. The cosine is just going to be 1/7. Okay, so you know we've got the cosine of the cosine inverse. We're in the first quadrant, so we're in an appropriate quadrant for cosine inverse. We really don't need to look at this picture, but I think it's going to help when we move on. So let's move on to the next one. And again, I've got the sine of some angle. So here's my unit circle. Sine is adjacent or opposite over hypotenuse. So what I've got here is a triangle where the adjacent side is 2 and the hypotenuse is 1, because this is really 2/1. So let's take a look at what's going on here. I've got the hypotenuse of a triangle is 1, but the opposite side is 2. And we know that the hypotenuse of this triangle has to be the largest side. So basically what this tells us is that for this particular problem, since we can't create a triangle where the opposite side is larger than the hypotenuse, is that there is no solution. Okay, so you really have to understand what's going on here, because there will be once in a while a problem where there is no solution. So if you're trying to find the sine or cosine and you're looking at sides of a triangle that don't work out because the hypotenuse is shorter than one of the other two sides, you're going to have no solution. Alright, so moving on to number 9, we've got the tan inverse, the tangent of the tangent inverse of -9/5. And again, we really don't need to do a circle for this one, but we will for a little practice. Since it's negative and we're doing tan inverse, I know it's got to be down here because the tangent has to be on this right half of the circle between pi/2 on the top and -pi/2 on the bottom. I know that this is opposite over adjacent, so the opposite side is going to be -9. The adjacent side is 5. I know that the 9 is negative because I'm in the fourth quadrant. And in the fourth quadrant, the x is positive and the y is negative. And again, this is going to be the tangent of some angle theta, which we don't really care about at this point. And it's just going to be -9/5. So once you get the hang of setting up these triangles, it's pretty straightforward to figure out what you need to. If you have all three sides of the triangle, then you can find the sine, the cosine, the tangent. We could find the secant or cotangent as well. So let's take a look at number 10. I've got the sine of the cosine inverse of -3/7. So I'm trying to find the sine of some angle. Since this cosine inverse, we're taking the cosine inverse of a negative number, cosine inverse has to be in the top half of the circle between 0 and pi. Since it's negative, I know it has to be in the second quadrant. So we'll call this theta. And cosine is adjacent over hypotenuse. So my adjacent side is -3. My hypotenuse is 7. I can find my y value, which I'm going to need to find sine, by using the Pythagorean theorem. So now if you're plugging this into your calculator, you have to make sure that you put the negative in parentheses, otherwise you will get the wrong answer, because the calculator is going to do order of operations, and order of operations, if you leave out the parentheses, says to do 3 squared and then take the opposite, which will give you the wrong answer. So, or you could just plug in 3. Anytime you square a number, it's going to be positive anyway. So -3 squared plus y squared equals 7 squared. So this gives us y squared is equal to 40, which means that y is equal to square root of 40. So that's 4 times 10. So that's square root of 2 is square root of 4 is 2 times the square root of 10. Okay, so now I can find the sine of theta. That's going to be the opposite over the hypotenuse. The opposite side we just figured out was 2 root 10 over the hypotenuse, which is 7. So it looks like a rather basic problem, but there's a lot of things going on here. You got to first realize that you're going to be in the second quadrant because this cosine inverse is negative. Then you have to use the Pythagorean theorem to find the opposite side. Then you put it all together by calculating the opposite over the hypotenuse. Alright, moving on to number 11. So we've got the tangent of the sine inverse of 1/8. So again, we have the tangent of some angle, we'll call it theta, and that's going to be the opposite over the adjacent. Since the sine inverse of a positive number is going on in there, we know we're going to be in the first quadrant. We could either be in the first or the fourth. And I know that this is going to be 1 and this is going to be 8 because sine is opposite over hypotenuse. And then I just need to find that x value. So I have x squared plus 1 squared is equal to 8 squared. So x squared is equal to 63. So x is the square root of 63. So that's 9 times 7. Square root of 9 is 3. Root 7. So now my tangent is opposite over adjacent. So 1 over 3 root 7. Which we will rationalize, and we get root 7 over root 7 times root 7 is 7. 7 times 3 is 21. So we have root 7 over 21. Alright, moving on to the last example. For this section, we've got the cosine of some angle theta. Okay, that's going to be adjacent over hypotenuse. We know the tan inverse of, so we've got tan inverse -2/9 here. Tangent is opposite over adjacent. And since we're negative, I know I have to be in the second quadrant because tan inverse can only be on the right half in the first or the fourth. So the opposite is -2. The y is negative because we're in the fourth. And the 9 is going to go over there. And we can calculate r, or the hypotenuse, whatever you want to call it. So r squared equals -2 squared. Notice the parentheses there. Plus 9 squared. R squared is equal to 85, which means that r is equal to square root of 85, which I don't believe simplifies. So now the cosine is going to be square root of 85 over the hypotenuse, the adjacent, which was 9 over the hypotenuse, which is square root of 85. And then we'll just rationalize. And we get 9 root 85 over 85. Alright, again, if you have any questions, make sure that you write those down so you don't forget to ask me, and we'll see you in the next video.